Hello, Cinecide here, and so I'm going to tell you why calculus, either, regardless of whether it's single variable or multivariable calculus, it was the most fun math course I've ever learned. I did learn on YouTube. It wasn't an actual school, but I learned it on YouTube from the organic chemistry tutor, along with 3 blue, 1 brown, and don't know who this woman was who taught Calculus 2, but it's much harder to learn than a regular Calculus 2 course on Organic Chemistry Tutor. Or it's not regular, but it was much harder than a Organic Chemistry Tutor Calculus 2 course. Because it was mostly like lectures from an actual university, given without credit without the stress though. But yeah. First chapter of calculus I learned was limits, and that I learned before I even started Algebra 1 in college, before elementary algebra, and I understood it. However, derivatives, that came after all that. It's pretty fun, like learning how you can decompose a polynomial through a heat equation, and you could flatten it out into a line at the x-axis with higher derivatives. Then integration, which goes into geometry, like finding area under a curve, arc length, all sorts of things. Integration by parts. It's all so much fun. Just like how listening to the song Asymptotic, it has a lot of references to algebra, trigonometry, and calculus. And then you learn about time equations with parametric and polar curves. And I still have some reading to do when it comes to like the integration. Well, I'll find that out before I teach that in my Secure Schools agenda. And sequences and series, that was Calculus 2, so it was pretty hard learning it from that woman who taught me online. So, but some of it was analysis based in my school. In Secure Schools, it's like most of the stuff you'll be learning in analysis. Like all sorts of variables that go beyond x and y and z and t. And then there's linear algebra, which teaches the variables I, j, and k based off the 3 dimensions: the x-axis, the y-axis, the z-axis, and vector spaces, and determinants that have to do with multiplication, basically multiplication of matrices. It's basically a lot like that. That's how I'll teach it. Keep tuned for all sorts of cool courses once the Quadrillion Company is done. Teaching on YouTube and on my own website is the most important thing after that. Don't know if my website's gonna have an edu on it, or edu, label. Anyway, multivariable calculus, where you're learning about adding a z-axis to an x. You have planes that function as limits, and gradient vectors as well are also planes. When you're trying to find out tangent lines of multivariable calculuses, or multivariable calculi, it's just like a plane, like a flat surface. Then the functions that you do in those courses are like algebraic geometry. At least in the elementary form, you're doing algebraic geometry functions stepped up to calculus level. And then integration, you're just adding another axis. or axis. Don't quote me on that, but it was really fun. And then there's partial differential equations, which comes in a more advanced course you'll learn later on in like junior or senior year of college, but in freshman year or sophomore year of college where you're learning this, it's much simpler. You're not using the Laplace or Fourier transforms or Laplace or Fourier series just yet. But yeah, calculus is really fun. It's a really fun math subject. Pre-calculus gets up there on my list of fun math subjects. Statistics I still need to read on before teaching it. But I would think statistics, since it's also college level math, it's also fun. Some people say it's harder, some people say it's easier than calculus, or pure math. Then what comes after calculus, differential equations, linear algebra, it's called analysis. And if you're old and you're thinking analysis is pre-calculus, that's not what they call it anymore. They call that pre-calculus, not analysis. Analysis is what comes after, not before calculus these days. You have real analysis, complex analysis, functional analysis, Fourier analysis, analysis of manifolds. You have like all sorts of things. And there are later analysis courses you'll learn in my graduate program that I'll be teaching, along with the calculus functions more in depth. It's not just undergrad. After analysis is nonlinear dynamics, or numerical analysis, and then right before entering grad school is modern algebra. Not to be confused with elementary algebra, which is what you take in high school or 8th grade. I took it in 9th and 10th grade. Elementary algebra. I still have some reading to do before teaching modern algebra at the undergraduate or graduate level. That's just going to be it. The video is getting long.